stop and look, you'll see it here. So there it's looking, identifies a trajectory. Then after it's looking, it identifies a trajectory and then goes and runs the trajectory. So we're not actually moving when it does video and then path planning and then just goes and runs it. So yeah, I think they stop looking at the video as soon as they identify that's the block, then they calculate a trajectory and just go.
And how did they come up with this spin, the wheel design?
Oh, in terms the lift or the
that disc there, the spin disc.
Oh, and the turret.
Oh, you call it turret. Okay.
Yeah. So yeah, it's got two differential drives. Okay, take a look over here. I'll show you one. So,
oh man, this is like a museum.
So this is the basic differential, right? It's one set of motors. If we turn them in the same direction, you get one rotation. If you turn the motors in the opposite direction, you get this differential rotation.
Gotcha.
Okay. So this is a robot from a couple seasons ago. So there's one set of motors that drives the lift out, forward and back. That's the common motion. And then this turret swivels back and forth with the differential, okay?
Yeah.
And then there's a set of arms on top of that turret, which is another differential drive. So one of them is this wrist, which goes like this, and the other one goes like this. So there's 6 degrees of freedom between the arms. So what they wanted to do was build an arm that could grab on one side and flip over and deliver on the back side. So you don't have to do a transfer or have two arms. And they really focused on, the big advantage of these differential drives is you've got this motion at the top, right? Like you have it cranked way up and you have this motion, but you don't have to have any motors. So all the weight is on the bottom of the robot. There's 7 motors on the bottom of the robot, and you don't have to have anything at the top of the arm. There's a couple of servos, and that's it.
So that way you only have a one linear system. You don't have you have having two.
The whole.
Oh wow!
All the drive motors on the robot are on the bottom.
Yeah.
So all the weight is on the bottom. It's super agile, fast, stable. Yeah. So 4 drive motors, 2 motors to run the lift in and out, and then one motor that pivots the lift. Right.
Wow.
So.
But still, with a 1, 2, 3 servo plus one
you've only got
gear, so it's still quite some weight on the.
You've got 3 small servos, kind of medium-sized servos here on the turret, and then the arm has just got this one.
So why you use this kind of a gear instead of just normal spur gear?
Because these center themselves. Okay, those 2 gears will always stay pushed to be in alignment.
Are you an engineer?
Yeah. The kids did this, but yeah.
But I know,
those kind of gears. I mean, they're impossible. You never see them manufactured because they're almost impossible to make, except for like a sintered gear. But in 3D printing, they self-align. And they've used them here too. You can see it's a small version of it.
Oh, so even your differential gear is 3D printed.
Oh yeah, all this is just PLA. Yeah.
What kind of PLA do you use here?
It's just standard. I think this is Overture PLA. It's just
regular PLA?
Special. Yeah. And the slides are linear bearings. And then on the upper part of the slides, it's carbon fiber on the plates in between.
Wow, this really
super light and very stiff. Yeah, the carbon fiber. It's just super rigid. To try it.
Oh yeah.
And light. So we made as many parts in the arm as we could out of carbon fiber.
Excuse me. So your kid in the team?
Yeah, one of my kids he's not around right now.
For a transmission, that's what 9 minutes.
So how long you have been coaching or mentoring?
5 years.
Are you parent mentor?
Yeah, we tell parent mentors. Yeah.
We may have had the.
Oh, so are you a community team or school team?
Well, we gained school sponsorship 2 years ago. So we started out as a community team. 2 years ago, we became a club at the school. So the school basically provides us some space, which we sometimes use.
But But then you got like the student coming through the school,
We collect students from the school.
which is nice.
Yeah.
That way, that you saw our bigger talent pipeline.
Right. Yeah. And that's nice. I mean, once the team gets a bit of a reputation, then you can gather
First of all, that's the same
students, right?
axle that's
Maybe a
kind of
little bit
attached
more
to
selective
our
about the
pivot in our
kids
lift,
and such.
and that
Yeah.
rotates the.
And how did the team do before you come on board?
Well, they came together. They were 2 years as an FTC
oh yeah,
team.
we had a
They
divvy
were
slide.
worlds once there. And then
Kinda
when
hard
they
to see.
became,
Yeah, we
when
have
they
two
were all,
diffvies.
whatever the age
I'd
was,
like
12,
to mention those,
they
but
decided
then
they all moved together
all the
into
motors
FTC.
in the base, and then
so
the
then this
second
is our
diffie
5th
is
season
just
as
powered
an
by
FTC team,
servos.
and
That
3
was
years
like
at
a
World.
standard
So.
kind of car
Been good.
diffie where you just have the.
And we're in Wisconsin,
third
it's a little bit
gear
tougher. We've got
attached
about
to the two pairs of
80
pedals.
teams,
Yeah.
and they'll send 2 or 3 to Worlds
sure.
each year.
All of
So,
them?
Oh wow, that's pretty competitive.
yeah, it's fairly
So
competitive.
one out of 40.
Yeah,
The similar to our region.
I
So
think many are like that,
Yeah.
So, yeah.
but great job, and I think I can definitely see you.
Yeah.
But you know, I
This
think.
is our lift mechanism. It's kind of hard to see on the robot, but you got 2 more minutes. So,
Oh, I got all the plans.
so we use a spool to lift the robot, a string and a spool. So the drive motors are here, and it's conventional drive, right? If you're driving, it just
Cool.
is the mechanism wheels independently, right? Just
Yeah,
standard
yeah,
stuff.
yeah.
And then for lifting the robot, we rotate this gear down into some gears
You got-
on
holy-
the drive motor.
Holy cow! This
Yeah.
is cool.
So then when you hit in the lift mode, this gear will rotate down, the drive motors go in a coordinated direction, and we pull the robot up and down. So in that way you've got the 4 drive motors are pulling the robot up for the climb. So you get it very fast. It's about 5 seconds for the third level climb. So, and then you don't have to have additional motors, right? You can use the same, because you don't need the drive wheels when you're lifting. So you can repurpose them for that. Yeah.
Well, you have great influence on the team.
Well, the team's really creative.
I know, but still.
I help them make parts. You know, like how do we do things?
But you know, this is the idea, right?
Yeah.
Because I'm parent mentor too. My undergraduate was engineer, but I haven't done engineer for many years.
Oh, sure.
But I totally understand that. You know, sometimes they are just kids, right? It's
Yeah.
the best time messing
Yeah.
around. They don't really have an objective. It's us that help them to stay on the path.
Right. Yeah.
Show them what is possible. So I mean that is really positive. You know, my hats off to you. That
thank you.
Because you show them what is possible.
What they can do. Yeah.
Yeah.
And we're pretty rigorous. We have a pretty strong design process. We actually do some systems design and take them through that.
Can you tell me more about
sure.
that?
So, in fact, right here is this is kind of the core of it, right? So we start with what's called a game point matrix. So they list all the functions that the robot can do. Put a pixel on the backdrop. This is from last year, I think, looking at it. Launch the drone, etc. And there's how many points it scores and how difficult it is. All right, so that gives you some direction. Where do you want to start? You want to do the things that score a lot of points that are easier, you know, and you begin there. And then they design, okay, those are the capabilities we want. Then we have them go through a process where they look at failure modes. You know, what can go wrong and how do we mitigate against that?
Oh, wow.
And then we challenge them to design subsystems. You know, what's the claw going to look like? What's the elevator going to look like? What's the drivetrain? And then they go through, you know, computer-aided designs for that, just prototypes. And then we challenge them to build subsystems. And typically, if we have 2 or 3 different ideas, we'll ask them to build 2 or 3 different pieces. Like I think we built 4 claws this year because there's different ideas, right? Different kids. So we build all 4. We do testing on them, which is faster, which is more reliable, and then that, you know, converges on the best robot subsystems, and then we integrate the robot and test it and kind of keep iterating from there. Yeah. That's the basic, you know, design process.
Wow. So this your last year award here, also here, right? Still have the same.
Last year's here. That's the same stuff. Yeah.
And to this also the award.
Power Play, we did not make it to Worlds.
Oh, the state third.
Freight Frenzy 2021, we were at Worlds. Yeah.
Gotcha.
Yeah, no, we've had a lot of fun. So
This is beautiful. This is beautiful
kids
stuff.
to learn and
Yeah.
We have 10 graduating seniors this year.
Okay.
So that'll be different next year. We brought on a whole bunch of student mentors this year, so we had 9 new kids
Okay.
that we got involved and ramped up, but it'll be different kids next year.
Yeah,
So it'll be same process, but it'll look a little different. We have a couple of really talented kids in mechanical design and software, which, I mean, the software stuff that I don't even understand, but that's been really nice to have.
Do you have working kids can be very exhausting. How do you keep going with that kind of energy?
The team is really good. We just give them some structure and they spend a lot of time. I'm lucky enough, I did retire about a year ago, so that made this season a little bit easier because I've got more time, especially with all the new kids, because this year was almost like coaching 2 teams. They're very experienced kids, and their main thing was don't slow me down. We got 10 seniors, they want to be at World, they want to be great. And we got all these new kids, so we got to find kind of parallel paths, right? So we've had lots of stuff going on this year, both projects to get the new kids up to speed and learn, and also make sure the 10 seniors are just going, So.
And how do you train other mentors?
When we bring a mentor in, so our standard process is we had, a team of about 15. We've been bringing in 3 or 4 students per year.
Okay.
So the students come in as student mentors. That's for the first year. So we list them as mentors, not team members, okay? But they get a team member to partner with. They get a couple of projects to work on, and we assign one of the coaches to them.
Okay.
So, kind of keep track of them, make sure they have some things to do, so they don't just get lost. And we do challenge them. There's a percentage. We're fairly selective recruiting kids. But we still have maybe 20% that drop out. Robotics isn't what I thought it was, or it's more time than I wanted, because these guys spend a lot of time. Right? And then for mentors, we're largely recruiting from parents of kids.
Okay.
So that's one of the factors when we recruit students is, what do your parents do? If your dad's a software guy, awesome.
I like that idea. I like that idea.
You're going to help.
I like that
and then
idea.
we kind of get the idea of who's interested in coaching, and the parents. There's lots of things for the parents, right? We have them step into the parents, do a lot of the, like planning logistics for all of this, and travel and food and everything. And then we have some technical coaches that are parents as well.
Gotcha.
Yeah.
All right, it's great. Great talking to you. I feel I learned a lot.
I'll give you a card when we walk out here. We can grab one from the
Sounds
front.
good. Yeah.
Yeah, and if you want to bring the team over to see some stuff or follow up anytime, send an email. We're happy to talk.
I appreciate our team.
Yeah, absolutely.
All right, I'm going to grab a car on the way out.
We're going to scooch by here.
Oh, yeah.
Thank you.
Jemison. Where are we on?
We can leave after.
Okay, because we have our
Okay.
So we need to pass.